Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Largest in Sight by Reb Baron. And here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 so that each row, column, and 3 by 3 box contains each digit exactly once. We have groups, where we need to divide the grid into groups of orthogonally connected cells. Digits may not repeat within a group. And cells separated by an X must belong to different groups. Okay. What is an orthogonally connected cells? It's basically cells that you can go from any cell in that group to any other cell in the group just by going through edges, all while staying within the group. So this is an example of a valid orthogonally connected group. This, however, is not, because to get from these cells to these cells to get from these cells to each other, obviously you can go through an edge while staying within the group. But to get to these cells, you cannot. You have to either go through a corner or go through an edge exiting the group of cells. So that's an example of an invalid orthogonally connected group. And digits may not repeat within a group. So they're like regions, but I don't know if they necessarily have to be including the digits 1 through 9. They could just be like they have to have no repeats within a group. We have circles. A digit in a circled cell equals the size of its own group. If a group has no circled cell, then its size must appear somewhere within that group. So a digit in a circled cell, so if this were a group, then this would be 1, 2, 3, 4, 5, 6, 7, 8. So this would have to be size of 8 in that case. Again, X's cell separated by an X must belong to different groups. If a group has no circled cell, the size must appear somewhere within that group. So if it's size 1, all the size 1 groups are just 1. Have to just have a 1 in it. All the cells of all the groups, it has to have a 1 in it. So every group, even if it doesn't has a circle, must have the size somewhere in its group. Okay, and that's how circles work, though. But we don't need every group does not have to have a circle, interestingly enough. We have arrows, where a digit in an arrow cell equals the size of the largest group seen in any of the directions pointed by the arrows. Okay. The arrow cell's own group is always considered seen. So that means, the arrow, the digit in this arrow cell equals the size of the largest group seen in that direction in any of the directions pointed by the arrow. And the arrow cell's own group is always considered seen. So that means this digit must be equal to the size of the largest group seen in this direction and this direction, and that includes its own cell. This is the largest group pointed in this direction or this direction and including its own cell. Interesting. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, we know these are group borders. We know this is a border, this is a border, this is a border. Anything with two circles that are in the same row or column or box have to be different groups. This is obviously a different group. Okay. This is basically the size of its group. So these cannot be the same size. So this is basically saying the size of these cells, the largest size of these groups must be here. So this is the largest size of all of these groups. It cannot be the same as that. So this must be the largest size of this region here, which means it's a different region than any of these, because otherwise then these would be the same exact number, which is not allowed by normal Sudoku rules. So we know this is a boundary. And this must be bigger than all of the groups here. So this is greater than that digit by 1. This has to have these 3. So that means one of these 5 has to be greater than this. So this could be 1 through 7. This is 2 through 8, and this is 3 through 9 there. So this has to be at least size 3. So these two are part of the same group. Again, you can't have repeats within a group. This is the size of whatever its region is. We don't know what that is. Can this ever be size 1? I don't think so, right? If this is 1, then you have 1, 1, and 1 there. So no, this can't be 1, which means this can't be 2. Can it be 2? No. Well, no. Because for 2, you have to have a 2 in its group. So it would be 2, and so this can't be size 2. It could be size 3. This can't be 3. This can't be 3 or 4. It's size at least 5. These are different. And they match both of these. So that means this one has a larger group somewhere in these cells. Obviously, it can't be that one. So one of these cells has to be larger than this one. Can't be 1, because then all of these groups would be 1, and they would have to contain a 1. Can't be 2 for a similar reason. Maybe 3? This is the largest of one of these two. This is the largest of any of these. This is the largest of any of these. So this So these can't be the same, which means this one must be smaller than this one. And we necessarily have to include both of these. So this is basically saying of these, which one's the... This is saying these have to be a certain size. This it includes that, but it cannot be the same digit as that, so this must be something greater this way. This is saying that these can't be the same, so this must be greater than all of the groups here, which means it includes this one. So this is the same as this digit here. So these digits are exactly the same because this one is saying it's not any set from here because otherwise it would be exactly the same digit, which is not allowed in normal Sudoku. So it has to be the blue one here, which means this cannot be part of the same group as this one. So this must be a border this way. This has to go blue that way. Therefore, this is not the same group. Because otherwise, if this were the same group, then this would see that group here, which is not allowed. Okay. And this has to be at least 5. This can't be 9 then. So this is 5 through 9 here. No 8 there. This cannot go here because then these two would be the same. So this cannot go here at all. So this has to go as a group like so. Well, like here at least. Technically, no, this can't just be one by itself. Because it would have to be then 1 in size. So this must be at least 4. So this is at least because... Oh, that's not true. You could have a 2 here. But we do have to extend out to here, and it's 5 in size at least. This must be the same digit as this, or it could be something higher. So this is 5 through 9 also. Hmm. Um... This can't just be 3 here. If it's just, well, technically it could, actually. It's very unlikely to. Because the problem is, if this is 3 going all the way through here, that means you can have 3 at most going this way, but each of them requires a 3 to be in its region, so that can't work. Then you could have 3 going here, maybe 2 going here, maybe 1, 2 going here, but that's not large enough. You don't have enough 3s in these rows for that to happen. So this can't actually be 3, which means this can't be 4, which means this can't be 5. So this can't be 5. It's at least 6 in size. You could have 6 going here, and then this being 2. That is potentially possible. You could have 4. There are enough 4s possible. You could have like 3 here and then 2 here or something. And then that would cover 3 rows or 4 rows. let's see. These cannot be the same either. If this continues on to here, that means this must see something larger than this. So this must see something larger than this blue. So if this blue cuts off here, then they could be different ones. But then this would be 6. If this obviously extends further as a group, then this cell also sees that group, and it cannot be the same as that. So no matter what, this cannot be 9. That means these are the same. This has to be less than that, so it's not 8, not 7. This could still be, it still sees this, so it's a minimum of A, which is at least 6. This is less than that, can't be 8, can't be 7 for the same reasoning. So this has to either, we don't know. Either this cuts off and it's 6. Wait, does it have to be 6 here? Couldn't it be 5? I think this could still be... No, because this is 4 and that's 5. This can't be 3 here. That's the reason why this has to be at least 6. Okay. So it could go that way, in which case this would be larger than that. But we don't actually know. Interesting. Okay. This sees this way and this way. So it's larger than this one. This is its entire row. We don't know. We don't have any comparison, though. This must be larger than this set. So we have potentially 1 through 8 here, and this is 2 through 9 here, because this is larger than that. This sees either here or here, so that's not helpful. This one must be larger than that, because it can't be the same digit, and this one sees the same as this arrow. So this has to be larger. And this is 1 through 8 there. It can't be 1, though. If it's 1, all 3 of these have to be 1 in size. And then they would have to all have a 1. So that's not possible. Can it be 2? No, because you can't... I guess, well, maybe you could have 2 here and then 2 there. That is potentially possible. Okay, so 2 is possible there. This is greater than that digit, so it's 3. So this sees all of these potential groups. This sees all of these and all of these. This sees this entire row. This sees only these 4 cells. This sees these 2. This sees this entire column. What do we know about groups? Well, how many circles do we have? 4, 5, 6, 7, 8, 9, 10, 11, 12. We have at least 12 groups. Hmm. Mm. Oh, interesting. This region cannot go to one of these circles here because that circle would have to have the size of that region, and this one points to this region specifically. So this can go here. It cannot ever go up above row 7. Sorry, above row 8. So if it's 9, it can't be size 9. 1, 2, 3, 4, 5, potentially 6, 7, 8, 9. That would be a size 9, but it can't be a size 9 group. Because if it crossed here, this has to find some group that's larger. Um, hmm. So this can never reach to the circle. Now that's interesting. If this does reach here, this must match essentially. Well, I mean, technically, it can't. No, it can't go here. Oh, this can't go down. Right, this can't go down at all. Because if it goes down, this will see that grouping. So this is border here. So this has to go this way, which means this is larger. It's 7, 8, or 9. So this is only size 6 or it's size 7. Which means this is less, so no 7, no 6 there. This is less, no 7, no 6 there. Obviously, this can't go that way. This can't go here. If it goes there, this is the same digit. Hmm. This sees something in one of these cells, which is larger than this. So that means it has to be its own region. Because it can't. So then this is size 4. So this must see size 4, and this must see size 3. And it could include here. So this is a set 3. This is a set of 3. This can't be 3. So it has to be size either 2 or 1 here. So the 4 in this group matches that. There's no 3 here, no 3 here, no 3 here. This cannot go that way because then... Actually, it could. It could be size 2. And then you have a size 3 like that. That's potentially possible. Interesting. So we have yellow that way. So the largest of these is size 3. This is size 1 or 2. This could be part of this group if it's size 2, and then you would have to have a 3 somewhere here, which could work. Which would have to have a 3 somewhere in this group. Otherwise, this could be 3 going that way. It could be just even 3 going that way, too. This could include itself. So this is either 6 or 7 here, matching this. Or it sees its own group. If it sees its own group, and that's larger, this would see that it would have to match itself. Oh, it cannot. If it sees the blue only, that means... So say this was cut off here at 6. The problem is this would then be 6. This would then be 6. So 6 couldn't be here. You would have to have a 6 here, which would mean that this would see its own region. If this is 7, obviously this would have to see 7 then as its largest group. And then this would have to be larger than that, because it would see the 7 and it would have to see another group that's larger than that. So either way, this is going to have to match its own region, right? If you try to have 6 here, 6 can't be here. That means 6 would have to be here, somewhere in the region. It'd have to be one of these 4, which eliminates 6 from being there. So this is matching its own region. So if it's matching its region, then it would be 7 this way, or it would be size 8 or 9. But the problem with that, then, is that... Okay, so, well, that's fine. That means these cannot be the same region, because this would... If these are the same region, this matches its own region no matter what. Whether it's part of this group... Sorry, not region. Group. Or whether it's part of some other group. Because it cannot... If it doesn't match, it can't match this, because we have to have the size of this in its own region. So if these are separate regions, this needs a 6. And 6 is here because that's pointing at this region. This is 6 also, so therefore 6 has to be one of these, which means that can't be 6. So this must be referencing its own region no matter what. So therefore, if this is part of that region, this would see something that's larger than 3. So this has to be then a boundary here. So that's a group, which means this is a group of 2. So this is a group of size 2. This cannot be the same region because, again, this matches its own region. And this must be greater than that group there. So whichever one this is, it has to be greater than that. So this is not 9. So it's 7 or 8 here. This must be greater than that. So then this has to be 7. So this is 7, which means it matches that. So this is 7. This has to be 8, because this must see something greater than the 7, because it already sees a 7 group. So it must have something greater, which means this must be even greater than that. So it has to be 9. So this must see a 9. This can't be 9. This sees size 7. So then this must see size 8. This can't be 7, 8, or 9 here. So this is size 7 also. It has to have a 3 somewhere here. It could be 3 here. Okay, it can't be just 3 here, because if that's 3 there, the problem is that this would have to be size... It can't be size 2. It can't be size 1. So one of these is a 3 guaranteed. We don't know which. And it has to be 1, 2, 3. 1, 2, 3. I guess it could be 1, 2, 3 there. So this is done as a region. This is size 2. We have 7, 8, and 9. This is less than that. So it cannot be 7, 8, or 6 even. This sees that direction, so it's less than 7. None of these can be 9. Okay. One of these could always be 1, right? 7 has to be one of these 2. No. So this can't be 7. If this were 7, then this would see a group of size 7, at least. So this can't be 7, which means this is 7. This has to be less than this, because this must see less than... This has to be less than that, so it has to be 1 through 4 here. It cannot be 4. It's 1 through 3 here. This must be less than these, so it's 1 through 3. Cannot be 2. Can't be 3. This must be size 1 as a group. We'll mark that as gray. No 1 here. It's 2 or 3. Because we already have a 3 in the box for this size. This is 2. That means this can't be 3. It has to be at least 4. Since it's size at least 4, I think this has to be 4. Because this is blocked off, it has to go here. It will be seen by both of these regions. So this must be size 4, which makes this 5, this size 6. So this can't be 6 here because of 6 in the column. So this is size 4. It has to go out this way. Well, let's color. Okay, so this has to go this way. This is size 2 or 3. This must see a size 8. So it's either... Oh, this can't be here. So it has to be its own region that it sees 8 in. Because if it goes down here, then these cells would see it. This sees less than 8. So it has to be like 8 cells here or 8 cells here. So this is all part of the same region. It can't go up and it can't go down. Because then it would be... It can't go here. Because then this would see it. So it has to be all 8 here. So this is a group here. That means yellow has to go here. So this is size 4. Oh, it doesn't have to go here. It could be 4. Oh, no, it can't go all the way down here. What region is this part of? Dang it. We can't have... Ooh, how does that work? I don't see how that works. Um... Hmm. Because this is blocked from any other region, so it has to go here as a group. But it's not going to be 1. This seems a little problematic. Huh. Yeah, it's a little problematic. Can't be 4 going that way. That would have solved a lot of things. This has to be part of this. It's just not going to work. Because the problem is, we could have 4 here, but then this would see size 4. And it can't be 1 or 2 because we already have 1 and 2 in the box. Ooh, that's not great. Wait, why can't this be 4? Yeah, that might work. I don't know how I got that was 1. Can't it, why couldn't it be 4? It could have. So I think we've proven that this can't be 1 then. Well, that's interesting. How did we know that's not 4? Oh, because I think I took that number here. So this has to be 4 here. Okay, that makes sense. This is 5. Right, this sees 8. It cannot go down. It cannot go up. Right, so that is... Then this is all one region. There we go. So this is 4. This must be 1. Because if it's 6, it would have to enter here, and then it would be seen by that. So this is 6. No 6 here. So this is still 1, 2, or 3. That's fine. We have 3 here. This cannot be all 3 that way. So this must be part of this region here. This is 1. One of these is 3. So we have 3 here or 3 here. You cannot have 4 going down here. You can't have another 1 or 2. So this is part of that those are part of the same region. So yellow has to go here. This cannot be of size 5 as a region here. That means 5 has to be going this way. It cannot include this because it can't be size. So we can't have a size 5 region here. Actually, this has to go yellow here, and that's done. So this is a yellow-red pair. We don't know which. So this is done as a region because it can't go anywhere else. This is 4, 5, and 6. Actually, this has to go 5 here, so this is at least 5. This is size 8. So we have 8 here, 8 here. This has to be broken up into multiple regions. So I think it has to be 2 and 3. Because this one has to see a 5 here. And this is going to be the size 5 region. So this is the size 5 region, which is done, because it cannot include the circle, because then this would have to be 5 also. So this is going to be a 2, 3 pair. So we know 2 at least are here. It could be 3 that way and 2 that way. So these are going to be 2 of some sort. And 3 cannot be here in this row because of 3 in the box. So this must be size 2, which forces this to be size 3. So that's a group. This has to have a 2 in it. We don't know which. 3 is here. This is size 5. So this must be size 1, because this has to see a size 6 region. None of these are size 6, so it has to be here. So this must be size 1. This is a size 6 region. It could include that, so that could very well be the case. This sees a size 8. That's fine. This sees size 5. It could be 5 or 6 here. This can't be 5. This sees one of these 2. Oh, this has to go out here because this can't. Well, no, it doesn't have to. It could go 6 that way. That's possible. No, this can't be 1. So this has to be part of this. So then this has to go out this way. So this is at least size 6 that it sees. But, okay, so we know this is size 6, which means this can't be 6. It must see a 7 size, so it has to be different. So it cannot be the same as that one, because its own region, it has to match. So this has to be blocked this way, this way. So this sees its own region of size 7. We have 1, 2, 3, 4, 5. It has to be 6 here. So that's done as a region. This sees a size 6, so 6 has to be here, which makes this 5. This can't be 5 or 6. Remaining digits in column 4 are 1, 2, and 4. This can't be size 1, so it has to go that way. This can't be size 1, so it has to go that way. This must be size 7. It cannot be part of this region. But it could go funky like this. This is not part of the size 9 region. So the size 9 region has to be somewhere here. This is size 6, that's fine. Cannot be 1, 6, or 7. You could have 2, 3, 4, 5, 8, or 9, technically. No 3 or 4 here, no 9 here. Can this really be 8 or 9? Unlikely. Oh, whoops. If this is 8 and 9, it would have to do something like that. Because it couldn't be pointed at here. So it can't be 9 because it would be here and then this would see it. Technically, it could be 8. 1, 2, 3, 4, 5, 6, 7, 8. Or I guess 8 there. No, because this can't see. This cannot see a region greater than 4. So all of these are size 2 or 4 here. 2 doesn't make any sense. If we have 2, you have 1, 2, 1, 2, 1, 2. And then this would be size 1. I guess that could work with 2 there, 2 there, and then 2 here, right? That would be 1. But this is never going, these can never be size 2 by themselves because this would be matching that cell. This would be size 1. Yeah, so this can't be 2, it's 4. That means this is 4, that's 4. Can this actually be 8? Probably not. This can't be 8. I think we've shown that, right? 1, 2, 3, 4, 5, 6. It can't go that way. So we have 1, 2, 3, 4, 5, 6, 7, 8, but then this is not a size 7 region, which it would have to be because this sees size 6. It has to see specifically size 7. So this can't be 8. I think this is similar, right? 1, 2, 3, 4, 5, 6, 7. Can't go here. Can't go down. It would have to go here, but then that would not be a size 7 region. So this can't be 8. These are 2 through 5. Remaining digits in box 7. We have 3, 6, 8, 9. Obviously, these can't be 3. That can't be 6. No 3 here. Oh, this can't be yellow because this would be the same region. So this must be red, which means this can't be red. So that's done there. We know this is size 3. This can't be 3. This has to be 1 or 2. We don't know which. So let's just double check. Arrows. So this is size 3. That matches. Size 1, size 2, size 3, size 4. Size 6, size 1. Where is 1 in box 9? Can't be here because of 1 in the row. Can't be here because of 1 in the column. So 1 has to be here. Remaining digits of row 7 are 1, 2, 8, 9. There's no 8 here because of 8 in the column. We know there's a 6 here. This has an 8. Okay, so this must have a 5 in it because it's size 5. So we know there's a 5. Okay, let's just do remaining digits. Remaining digits here are 2, 3, 4, 5, 8, 9. 5 has to be in this orange 5 region. So this cannot be 5 here. No, 3, 4 here. This can't be 2 because of 2 in the row. So we know there's a 5 here. This has to be 2, 5, 8, 9. So one of these two is a 5. That means remaining digits in row 8. We have a guaranteed 4 here. This cannot have a 2. So 2 has to be one of these 3 digits. That leaves this as 4, no 2 or 5, no 1, 3, 7. It's 6, 8, and 9. And this has to have a 5 here. So this is 5, no 1, no 2. So 5, 6, 8, or 9 there. No 8 here, no 8 here because of 8 in the column. This is 5, so this cannot be 5 there. This can't be 8 because of 8 in the row. This must be less than 4. And it cannot be 1 or 2, so this is size 3. That makes this a 1-2 pair here. This has to be at least size 4. We don't know which. So this is size 3. Remaining digits of column 3 are 4 through 9. No 6, 7, 9 there. No 6, 8 there. No 8 there. No 5 there because of digits in the row. So this must see a 9 somewhere here. This is going to be its size of 1 or 2. This is going to be size of 1 or 2. So as a 9, it has to be taught this, and it cannot include here for the 9. It could include here. No, it can't. If it included here, the problem is this would see a 9 size. So this must be a region by itself, and then this must be size 9. That eliminates 9 here, so that's 8. No 8 here. 8 eliminates 8 in the rest of the row, so this is a 1, 2, 9. This can't be 2. This is a 1, 2, 9 triplet here, which eliminates 1, 2, and 9 in the rest of the box, so this can't be 9 there. This is a 6, 9 pair here. No 9 here. So 9 has to be one of these 2 digits here. So this is a region by itself. Because it's bounded by what's seen here. This can't be 2. If this is 2, it would have to go that way. This would be 1, and then this cell would not have a group. That works. So this must be 2 here. This is 1 that way. And this must be group here, group here. This could just be 3 that way. We don't know. Light, dark. This must see one of size 4, which could include itself. This must have a group of size 7, which does not include this one. It can't go anywhere here. Oh. It can't be part of these 2. It cannot cross here, because then it would be seen by these. It can't cross here, because then it would be seen by that. So then this is its boundary. So this is 7 that way, which makes this a 2. So then this has to be 5. There's no 5 there. One of these 2 is a 5. So yellow has to go down. That's size 5. Size 2, size green. This cannot be just size 2 or size 1. It has to be size 4. So that's done as a group. And then we need size 3 and size 2. This can't go just this way, because if it goes that way, this would have to be a size 1 group. So it must go this way. And then this is a size 2. And then this is 2. We have a 7 here. That means this can't be 2 here. We need a 2 in this grouping. So this is 2, which makes that 1. This can't be 9. This can't be 7. So now it's probably just normal Sudoku. Interesting. No 2, 3, 4 here. No 2 here. This is one of these is definitely an 8. Okay, remaining digits. This was actually very cool. I like the whole idea of this grouping versus regions. That's fine. Remaining digits in. So this can't be 8 because one of these 3 is going to have to be an 8. Let's just fill out what these can. Well, Where is the 1 in row 1? Can't be here because 1's the boxes. Can't be here because of 1 in the column. So 1 has to be there. 1 has to be one of these 2 here. 1 can't be here, but 1 could be any of these 3. That's fine. 2's. 2 in column 2 has to be one of those 2. Cannot be here. So 2 has to be one of those 2 in column 6. Cannot be any of these. Can't be here. So 2 has to be one of these 2. So no 2 here. This can't be 5 anymore. Where is the 5 in box 9? It has to be here. So that's 5. 5. Where's 5 in row 4? Can't be here because of this is filled out and this is 5 in the box. And 5 in this grouping has to appear somewhere, and it can only appear in one of these 2 spaces. So this must be 5 here, which means this can't be 5. So we know 5 can't be here. 5 is one of these 2 digits here. 5 can't be here, which means 5 is one of these 2. Do we do 3s? I don't think we did 3s yet. 3. This can't be 2. Remaining digits in box 3 are 3, 4, 8, 9. No 3, 4 here, so it's 8 or 9 there. This 8 eliminates 8 here, so that's 9, which eliminates 9. This can't be 8 or 9. No 9 in the rest of the box. No 9 in the rest of the column. Remaining digits in box 2 are 2 through 5. No 2 here because of 2 in the column. No 5 here because of 5 in the row. We have a 3, 4, 8 triplet in row 3, which eliminates 3, 4, and 8 in the rest of the row. So this can't be 3 or 4. It's 2. That eliminates 2 from being here, so this is 2 there. No 2 here. That means the remaining digits here are 6 and 7. This can't be 7 because of 7 in the column. So this is 6 and that's 7. Remaining digits here are 3, 4, 5, and 8. And this can't be 3 or 5 because of 3 or 5 in the column. So this must be 3 here. That leaves the remaining digits in column 2 as 5 and 8. This can't be 8 because of 8 in the row, so that's 5, that's 8. There's no 5 here, there's no 8 here. 8 eliminates 8 from being here. This is a 4-5 pair, which eliminates 4 and 5 in the rest of the box. 3 eliminates 3 here in the rest of the row. So this can't be 4, it's 8. Remaining digits in column 1 then are 4 and 9. So no 4 here. Okay. We have a 3, 4. Actually, we have a 4, 5, 6 triplet in column 5, which eliminates 4, 5, and 6 in the rest of the column. So no 4 here. That's 3. That leaves the remaining digits as 1, 7, 9. And this can't be 1 here because of 1 in the row. Let's just remove these. This can't be 3. We have a 4, 5 pair in row 1, which eliminates 4 and 5 in the rest of the row. So this can't be 4. It's 3. No 3 in either of these spots. Okay, that was 3. Has to be one of these two. 4. No 4 here or here. Let's just do remaining digits. That might be easier. Remaining digits row 4 are 6 through 9. No 7 or 8 here because of 7 in the column, 8 in the box. No 7 here because of 7 in the column. No 9 here because of 9 in the column. Column 7, we have 6, 4, 6, 8, 9. No 8s in either of those spots because of 8s in the row. Remaining digits in column 8. We have, okay, this can't be 6 because of 6 in the, 7 cannot be repeated in that region, so this can't be 7. This is 9, that makes that 6. No 6 or 9 here, that's 8, which makes this 7. The remaining digits of column 8 are 1, 2, and 8. Neither of these could be 8, so this is a 1, 2 pair. This can't be 2, so that's 1, which makes that 2. There's no 2 here, no 2 here. That's 8, which makes that 2, which makes that 9. 9 eliminates 9 here, so it's 6 and 9. This cannot be 8 here because of 8 in the row, so it's a 4, 6 pair, which eliminates 4, 6 in the rest of the box, so this can't be 6, it's 5. This can't be 5 or 6, it's 8. 5 eliminates 5 here, so that's 4, which makes this 5, which makes that 4, which makes that 5. 9 eliminates 9 here, so that's 1, which makes this 9. This can't be 1 or 9, it's 7. 4 eliminates 4 here, so it's 6 and 4. We have a 1, 3 pair here. This can't be 1 because of 1 in the row, so that's 3, that's 1. 9 eliminates 9 here, so this is a 3. This 3 eliminates 3 here, so it's 4 and 3. 4 eliminates 4 here, so it's 8 and 4. No more 4 here. 4 eliminates 4 here, so it's 9. Oops. It's 9 and 4 there. And 9 eliminates 9 here, so it's 6 and 9. 7 eliminates 7 here, so it's 6 and 7. Very cool, actually. Very interesting logic here. Would I consider it very hard? For me, it wasn't. But I could sort of see why people would consider this very hard. Because it's not very, I mean, this logic of what it sees isn't very intuitive. And even for me, it took a while to get the hang of it, to understand what that means when it limits the grouping. It's not the very hardest for me. But the question is it just hard level difficulty? And I don't know if I can say that it is. I think it's still like the logic behind it could be very hairy, right? I don't know. Either way, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.